Hi everyone, welcome back to my channel. In today's video, I'm going to be telling you a very easy integration trick you can use so you can apply this in case of definite integration to save time in MCQs. So you have the integral of x cubed plus 1 dx. If you were to regularly solve this integral, you would have to first take the integral of both sides, then you have to apply your power rule, and then you have to substitute the limits in, and then take the upper limit minus the lower limit, and finally get an answer. But instead of doing all those calculations, which takes 4 to 5 steps, I'm just going to teach you a very easy trick you can use. So whenever you have the integral of a certain function, and the limits always start from negative a limit to a, right? Whenever you get a function like this, we have to check if it's odd or even. So in case this function is even, it would just be twice of the integral of 0 limits to a, and it would just be the function. But in case this is odd, then this entire integral would just be 0. So this is a very useful trick you can use in solving any integrals. So if you look at the integral above, how do we tell if it's an even or odd function? Obviously by splitting it up, because 1 car inverse is just 1, so we can't say if that is even or odd. So we'll have to take the integral of both sides. We'll take x cubed plus of the integral of 1 with these particular limits. Now if you look at x cube here, we have to check if it's odd or even. So the function of x would just be equal to x cube. So the function of negative x would also be negative x cube, because the power as well is an odd power. So obviously this would be an odd function, and since the limits are negative to positive, this entire thing would just be 0, right? This entire thing would just be 0 plus of the integral of dx, which is just x. So you have x with the particular limits, right? So you have to just substitute the values in. So just be 2 minus of minus 2, which is just 2 plus 2, which is 4. So using this trick, you can solve it. Whenever you have an integral like this, we have to first check if the function is odd or even. If the function by chance is odd, you have to just substitute it as 0, and you can avoid a long calculation by just using this trick.